Okay, so in this video, we're going to take a look at how we can factorize what we call binomials. And remember, a binomial is going to be something with two terms. So for example, x squared take 9, or something like x squared take 16. Okay, so both of those are binomials because they've got two terms. Okay, and the way that we're going to factorize these binomials is through this magic little formula, which says that a squared take b squared can be factorized into these two brackets, one with a plus b inside and the other with a minus b inside. And how can we prove that that's true? We can prove that this is true like the last videos that we were learning about by simply crab clawing or expanding these brackets out. So let's do a times a is a squared. A times negative b is going to be negative ab. B times a is going to be positive ba. And then b times minus b, we've got minus b squared. Okay, and remember, we can write this minus ab or plus ba. It doesn't matter which way around we multiply these. So let's rewrite this as a squared take ab plus ab take b squared. So it doesn't matter which way around we write that ba or ab. We're just multiplying them together. So order doesn't matter there. What about now? Well, we can cancel some of this out. We can go a squared and then minus ab plus ab. Well, that's just 0, right? If we've got minus something and then we add the same thing, it's just going to be 0. So minus 2 plus 2 is 0. So they cancel and we get a squared take b squared, which is exactly what we needed at the start there. So we've got this magic formula now, and I'm going to rub this out now that we've sort of proven it to be true. Okay, tidy that bracket up. And that is going to be our magic formula to go by. So for example, let's take this one over here. Let's take x squared take 9 first. Well, if this is of the form a squared take b squared, then we can factorize this no problem. We just chuck it straight over to this right-hand side here. So x squared take 9, well, we've got, instead of a squared, we've got x squared, so that's good. But minus 9, we've not really written that as something squared yet. Well, how can we write 9 as something squared? Well, 2 squared is 4, 3 squared is 9. So let's write 9 as 3 squared. So let's rewrite this as x squared take 3 squared. And now we've got something that looks exactly like a squared take b squared, except instead of a, we've got an x, and instead of a b, we've got a 3. So we've now got a is equal to x, and b is equal to 3. Okay, so we've just, instead of an a, we've got an x, and instead of a b, we've got a 3. So we can put that straight into our right-hand side here. So this is equal to x plus 3 times x minus 3. So that's how we're going to factorize these binomials. Let's do another example. Okay, let's do one in green here, which is x squared take 16. Okay, well, once again, we've got our sort of a squared part looking okay. That's going to be an x squared, so that's not a problem. But our take b squared part, at the moment, that's just minus 16. That's not really something squared yet. How can we write 16 as something squared? Well, 16 is a square number, which is great. That means that we can write it as x squared minus 4 squared, right? Because 4 times 4 is 16. So the numbers that we're looking for a lot of the time through this section of factorizing binomials are going to be the number 1, which is 1 squared, the number 4, which is 2 squared, the number 9, which is 3 squared, the number 16, which is 4 squared, 25, 36, 49, 64, 81, 100, 121, and 144. They're going to be our crucial numbers throughout this little section of factorizing binomials. So here, instead of a 16, which is one of our magic square numbers, I'm just going to write 4 squared. And well, now my a is equal to x and my b is equal to 4. So I can just put that straight into my brackets, my formula on that right-hand side. So I get x plus 4 times x minus 4. Let's do one more example like this, okay, before we dive into perhaps some trickier ones. So let's rub these ones out. Going to do another example And this time it's going to be very similar. I'm going to do x squared minus 25. Okay, so we've got our a squared part looking pretty good, but we don't really have something squared for our b squared part. So how can I rewrite this? Well, I recognize that 25 is one of my magic square numbers on the right-hand side here. So I rewrite this as x squared minus 5 squared. And now I can put that straight into my formula on the right-hand side. So I get x plus 5, x minus 5. Okay, because my a is my x and my b is my 5. Let's do some trickier examples now. So we'll rub that one out. And the same principle applies. It just gets maybe a little bit less sort of looking like that perfect form that we've just done. Let's do one that is perhaps, let's go for 1 minus x squared. Okay, so now our x squared sits somewhere else. It's not the end of the world. The same principle applies. We've got our b squared term looking pretty good. That's going to be our x squared. So we've got a nice squared going on there. But what about our 1? How can we write the number 1 as something squared for our a squared part? Well, the number 1 is one of our magic numbers. So I can write this as 1 squared, because 1 squared is 1 minus x squared. Now I've got it looking nice like my a squared take b squared up here. So I punch this straight into my brackets on the right hand side. I get 1 minus x times by 1 plus x. So that is going to be my answer there. Note, if we had a question that was x squared minus 1, we could write this as x squared minus 1 squared, except our brackets now would be x minus 1, x plus 1. So see how these are in fact different. So it does matter which side your x squared is on, okay, as to where it's going to sit in the brackets, which makes sense. Let's do another example now. So we'll delete this one. And the one that we're going to do now is x to the power of 4 minus 49. Okay, well, first off, I realize that 49 is one of my magic square numbers. So I can immediately write that as 7 squared. What about my x to the power of 4 though? Well, x to the power of 4 can be written as x squared all squared. Because if we think about what x to the power of 4 is, that's x times x times x times x. And what is x squared all squared? Well, that is x times x times by itself. So x times x times x times x. And well, that's just 4x's like we had over here. So whenever we have x squared squared, we multiply, this is one of our indices laws that we've learned, we multiply these two numbers together. And in this case, 2 times 2 is 4, which is what we need. So now we can write that as x squared all squared. So putting that into our magic formula that we have in the top right-hand corner, we get x squared plus 7 times x squared minus 7. Okay, let's do another one. Okay, and we'll make this the last one for this little section on factorising binomials. Let's do 8z. So instead of x's this time, I'm going to use z's. 8z to the power of 6 minus 32, and then I'm going to have a p squared. Okay, so this time I've got 2 variables, but it's okay. It's not the end of the world. First of all, we notice that none of these are magic numbers. Our 8 and our 32 isn't a magic square number. So what can we do here? We can actually bring out a common factor first. So if we take out a common factor of 2, let's see what happens here. So let's bring a 2 out the front. I now get 4z to the power of 6 minus 16p squared. So I'm going to divide everything by 2. And now I see that I've got these lovely magic square numbers, the number 4 and 16. Bingo. So what can I do from this? Well, I need to rewrite this as something squared minus something squared. So we'll keep our 2 here outside our brackets. And well, I want to write that 4 as 2 squared. And that z to the power of 6 is going to be z to the power of 3 all squared. So I can write this as 2z cubed all squared. And let's check that that is in fact correct. Because if I did 2z cubed times 2z cubed, I can do the 2 times 2 to give me 4. So that's the 2 times 2 to give me 4. And then I can do this z cubed times this z cubed. And remember, we add indices to get z to the power of 6. So I get 2z cubed all squared is one of the parts. And then likewise over the other side, I'm going to write this as 4p all squared. And let's check that that works, because 4p squared is 4p times 4p. And well, that is, I'm going to do the 4 times 4 to give me 16, and the p times p to give me p squared, which is exactly what I need. So I've not done anything wrong there. And now I can write this in my brackets using my magic formula up the top right there. 2 outside of, and my brackets are going to be 2z cubed plus 4p. Oh, I'm going to run out of room. Times 2z cubed minus 4p. And, I mean, I could remove those blue brackets if I wanted to. We could just write this like this. 4p, 2z cubed, take 4p. Now, what's the best way to check that this is in fact correct? This is a really hard question, about as hard as they come. But we can check that this is correct by expanding it all back out. Okay, tedious, but it is worth it. So let's expand it out. Let's hold on to the 2 outside for the time being, and let's just expand out these brackets. So we get 4z to the power of 6 here, minus 8z cubed times p, plus 8pz cubed minus 16p squared. And notice how this minus 8z cubed p and this plus 8z cubed p are going to cancel out to give us 0. So we now just get this bit here left. And if we expand the 2 into both of these, we get 8z to the power of 6 minus 32p squared, which is exactly what we needed up the top there. So our answer is in fact correct. Okay, so that's it for factorising binomials. Okay, it might be worth watching this video once or twice to really get your head around it, but definitely practice on the worksheet that's attached to this video.